चला आता we can start our last lesson number 8. Okay, and now this lesson is regarding discontinuities. Now you know the this difference between discontinuities and defect. Now discontinuity means what? The indication which will not affect life of job or performance of job. We can say discontinuities, and the defect means the indication which will affect life of job or performance of job. Then we can say defect. So this is the and definition of indication is response from continuity broken or signal from continuity broken. So please remember that three definition. One is indication, second is discontinuity, third one is defect. Now indication means signal from continuity broken, signal from discontinuity. Discontinuity means the indication or continuity broken which will not affect life or performance of job, that is known as discontinuity. And third one is defect. Defect means again the continuity or indication which will affect on life of job or performance of job, then we can say defect. So basically there are that discontinuity, there are three types of discontinuity that is based on processing stage of manufacturing. Means for example, one is inherent discontinuity, second one is processing discontinuities, third one is service discontinuity. Ata inherent discontinuity means it is while we are making ingot at initial stage, at beginning stage of steel manufacturing or steel making process. That time some of the discontinuities came in ingot, that all, for example, porosity, shrinkage, cavity, that all goes to inherent discontinuities. Second is processing discontinuities. Now see, casting is a process, forging is a process, welding is a process, heat treatment is process. While you are doing these processes, and if you are getting any discontinuities, then we are saying processing discontinuities. And last one is service discontinuities. That means suppose we have one pressure vessel, and that pressure vessel is working from last 3 years, but today we are getting one surface crack. That is service discontinuities. Now here we can see in details inherent work discontinuities related to the melting and solidification of original ingot before it is formed into slabs, blooms, billets. Inherent cast discontinuities is related to the melting, casting and solidification of cast articles. They are usually caused by inherent variables such as inadequate feeding, jetting, excessive pouring, temperature, entrapped gases. So, discontinuities, however, during the manufacturing process, many discontinuities that were subsurface can be made open to the surface by machining, grinding, and other ways. For example, suppose if you have one rolling bar and there is one discontinuity which is just 1 millimeter from top surface, and you are doing now machining, and in machining you are removing 1 millimeter outer layer, then that discontinuities may be open. So that's they are trying to say that one. So remember that discontinuities are not necessarily defect. Any indication that is found by the inspector is called a discontinuity. Huh? Any indication that is found by the inspector is called a discontinuity until it can be identified and evaluated as it to the effect it will have on service of part. Then the classification of discontinuities. The greatest aid in interpretation is knowledge of what is likely to be present in any given instance. Knowing the history of part, what is made of what of and what process it has been through, all form important consideration. Means suppose you don't know how that product is made, either forging, casting or welding. If you don't know that manufacturing process, then we can't expect perfect detection in NDT. So if you are NDT inspector, you should know what type of defects occurs in forging, what type of defect occurs in casting and welding. If you don't know which type of defect is there, then we can't detect any discontinuities. We can't do testing properly. So that's why, as a NDT inspector, we should know what type of defect came in weld, what type of defect came in forging, what type of defect in casting, and location as well. We should know. Then based on location, we can use MT, PT, VT, RT. So one technique cannot detect all discontinuities, because every discontinuities location will be different, and we have some techniques which will detect only surface discontinuities, some it will only 1 2 millimeter surface and one up to 1 2 millimeter, and others subsurface. So we have to choose that each method based on manufacturing process history, previous history. Okay, then every magnetic particle pattern produced is due to some magnetic disturbance set up in leakage field. The inspector must be able to determine whether there is serious crack or some insignificant or unimportant non-relevant indication. For example, suppose you are doing magnetic particle testing of weld joint, and the weld, there is weld visual is not good, means weld is not smooth. Then whenever you are doing, suppose you are doing testing, so some of the powder is accumulated because of rough surface. So that is not defect, but that is there is indications. So we can say that is false indication. Okay. Second thing, suppose if you are doing magnetic particle testing of weld joint, some of the indications occurs at some of the indications seen on HHZ area. Uh, and we can't say that is defect immediately, because in HHZ area there are chances to change the properties of material, and if properties of material changes, that means permeability of material changes. So if permeability changes, then we will get indication there. So that's why we have to ensure. Then how you will ensure that that is really non-relevant indication, or that is uh, real indication? Then we have to do heat treatment. Or we can do another NDT techniques. Even I am telling you, one NDT technique is not sufficient to ensure. So we have to use alternative NDT method as well. So there are many ways to see that is relevant or non-relevant. But in case of magnetic particle testing, if suppose indication came because of change in properties, that indication will not appear after heat treatment of that part. In case of weld, after PWST, post weld heat treatment, that non-relevant indication will not occur, because whatever property change was happened during welding, that will be uniformly covered, or we will get uniform structure after PWHT. Now every magnetic particle testing pattern produced is due to some magnetic disturbances. That magnetic disturbances means what? The change in permeability, or sometimes change in geometry as well. Set up in leakage field means some line of force will came out. That means leakage field. So in our work is to identify, to evaluate properly, to interpret properly. It is real indication. If real indication, then what is length, what is width, and what is the size of relevant indication, that we have to see. Now see here, the indication is seeing very nicely. A sharp indication, surface indication produce sharp, distinct, clean cut, and tightly held pattern. Why tightly held indication? Because of there is a lot of magnetic field, strong magnetic field will appear on the surface of job, because the defect is open to the surface. So many line of force came out of job, and there is a strong leakage field. If leakage field is strong, and then you are applying iron particle there or ferromagnetic particle there, then the powder will held tightly. But in case of subsurface, some of the line of force came out, so field will not strong as compared to surface indication. Now subsurface indication tends to produce indications which are less distinct, forming diffused and or fuzzy pattern. Now, non-relevant indication. There is group of non-relevant magnetic disturbances not due to discontinuities or actual break in the metal. Now, non-relevant. See here, if your material actually breaks, then it is true indication. But here physically there is no break in material. Then also powder is accumulated here. See, the powder is accumulated because of geometry. Because line of force coming from here, it is not suddenly going like this pattern, it will came out. And if line of force leakages, then there is pole formation, and we are getting indications. So a common non-relevant indication be caused by constriction in metal through which line of force must pass, such as shaft with keyway. Now see, shaft and keyway. So there is also some of the line of force will came out between that shaft and keyway. Not some of all, because the shaft and keyway there is gap, and in the gap here line of force will not move. Huh? So non-relevant indication can caused by the following are reasons. For example, excess magnetizing current. If your job requirement is 200 amperes, and if you set 400 amperes, then what happens? Excessive magnetization. That's why if you are applying more current than requirement, then some of the line of force will came out and you will get indication. So that's why we are using lowest current, which will seen on, which will detect the discontinuities. So then structural design. Now see, this is the design, right? This is the design, different design. So line of force coming like this, and suddenly it will came out here. Then permeability variation. Suppose sometimes we are doing cold working. In cold working, we are not getting permeability throughout the plate is uniformly. So some places permeability is different, some places permeability is different. Then whenever there is change in permeability, the resistance to line of force will be changed. So some of the line of force will came out and you will get indication. So that is also non-relevant indication. But that non-relevant indication we can't get after trace relieving. Once trace relieved, and if you are rechecking magnetic particle testing, re-examining magnetic particle testing, you will not get that indication. But true indication you will get before trace relieving, and as well as you will get after trace relieving as well. So please remember, these are three causes for non-relevant indication. First one is excess magnetizing current, structural design of article, variance of permeability within the article. Now, due to over magnetization, see, because of this slot here, you are getting indication. Because of over magnetization. If you are putting proper current, setting proper current, then you will not get this indication. Here also same things, you are getting indication. Here also see, some of the line of force came here outside because the job is not circular. If this, suppose consider the job is circular, maybe this line of force will not come outside. But because here sudden change in cross section, that's why the line of force will come out and you are getting indication. Now see, like the geometry suddenly change in job uh, geometry, then some of the line of force will jump like this and you will get indication. Now you know the here permeability. Now suppose here because of this bending, the hardness of this particular position will be different from this position and this position. If hardness changes, that means permeability changes. That's why if change there is no uniform permeability, means some of the line of force will came out and you will get indication. Now, permeability difference in the part can also cause non-relevant indication. Cold working a metal can change the permeability. Example, bending and straightening a nail will cause the metal to become hard at the point of bending. When the nail is magnetized, there will be flux leakage where the permeability changed. Because if there is not permeability is not uniform, line of force resistance will be different. And so some of the line of force will came out. Now see this, everyone knows this chisel. Here is hard, here is soft. So here is permeability different, here permeability is different. And we know the magnetic field means what? Line of force. Suppose the line of force coming from this area and here permeability is different, here permeability is different. That's why some of the line of force came here outside, it came out of the job, and we are getting north south pole and we are getting indications. That's why we know the history, we know the all these things. If you know there is change in permeability, then you will understand, yeah, there are chances of non-relevant indication. And you see the non-relevant indication, you see the look like this, but sometimes there it is very difficult to identify non-relevant indication and true indication, because you will see the same sharp indication. That's why then what will be the our role? We can do either heat treatment, if possible. Not possible, then we can do alternative method. So there are many ways to ensure that is non-relevant indication, but don't leave it okay or not okay like this. You have to interpret, you have to evaluate very nicely. You have to judge that is relevant or non-relevant. If not, if non-relevant, then leave it. If relevant, or if you have doubt that may be relevant, then you have to use penetrant testing method as well, or you have to ask for heat treatment. Is operation is there or not? If you have to ask, some this indication is came because sometimes 50% material is carbon steel, another 50% is different material. That's why also you are getting indication at the junction of that two material, because we know the permeability will be changes according to material. Stainless steel permeability different, ferrous carbon steel, low carbon steel permeability different. Okay, so these are the things here we have to ensure, we have to correct. Now this processing, machining is a process, forming is a process, extruding is a process, rolling is a process, welding is a process, heat treatment is a process, and plating is a process. So these are the process. While you are doing these processes, you will get the indications, and these indications we can say the that is processing discontinuities. Okay, then service, trace corrosion, fatigue, erosion, trace corrosion. Now, fatigue means fatigue. The vessel is working under load from long days, long years. Then we are getting the indications. Okay, so that is the fatigue. Erosion means in pipeline there is elbow. Means elbow means suddenly change. Pipe flow suddenly change. So at the junction, at the corner, the mechanical removal of material, that is known as erosion. Erosion means mechanical removal of material, that is erosion. Uh, so this ingot means during first beginning of steel making. So what we are doing, we are collecting raw steel, coke, limestone, and we are melting and heating, melting and solidifying, and we are getting uh, ingots. And that ingot we are getting porosity, non-metallic inclusions. By porosity is because of entrapped gases. Non-metallic inclusion caused by impurities accidentally included in the molten metal. Pipe, pipe means shrinkage cavity, because caused by shrinkage at the center of the ingot as the molten metal solidifies. Because we know the metal will occupy more space in liquid state. And while after solidification, it will occupy less space because of shrinkage. That's why we are getting cavity at the center. Now see, this cavity may be here as well. We can't say only on top side, but non-metallic inclusion always on top side. Why? Because non-metallic inclusion density is very less and steel density is high. That's why it came out. So generally this hot top we are removing. We are not using for further processing. This is the first stage of steel making process, that is ingot. After that we are using for we are using next operation rolling, or we can use casting, or further we can do forging, casting, rolling, whatever requirement. This is the first beginning of the manufacturing, beginning of steel making process, ingot making. Now after that, suppose now this is cavity here. Suppose here is cavity, and if you want to rolling, then what happens? Suppose here is cavity. Okay, here is cavity, and after that you done rolling. In rolling, your job also this ingot will pressed. Maybe rectangular, maybe square. So that defect also. If suppose now after rolling, suppose this ingot is made like this, then what happens? This size reduced. That's why this defect size also reduced. Here this diameter is more, but here is smaller. This thickness is reduced. This flat defect is known as lamination. So these are lamination, but this lamination comes in rolling. So in rolling. So in when the ingot is further processed into slabs, blooms, and billets, okay, it is possible for the discontinuities to change size and shape. As the billet is flattened and spread out, non-metallic inclusion may cause lamination. Pipe and porosity could also be caused lamination in same manner. So lamination is rolling defect. Now you see the stringer. This is non-metallic inclusion. You know, in ingot stage we are getting non-metallic inclusion because of accidentally mixing of non-metal. But after rolling, the size and shape of this non-metal will be changed. It's like this, and then we can say stringer. So stringer is also rolling defect. Now see here is open crack on ingot, and that is not closed in rolling as well. So this defect we can say seam, because seam is also rolling defect. Sometimes what happens, this roller marks also, because of roller marks, there is a impression on job. So that is seam. uh, See, the seam is here. Now forging, see this rolling means what is the rolling process? In simple way, we are heating the metal up 800, 900 degrees Celsius, and we are passing between rollers. So before rolling, the diameter is 100. After rolling, it will be 90. Like this, reduction of material. In forging also, we are hitting about 900, 1000 degree, 1000 degrees Celsius, and we are keeping between dies. There is one bottom die and one top die. Bottom die is fixed, and top die is movable, up, down, up, down, up, down, and the both die having desired shape of component. Okay. So that desired shape of component, and sometimes what happens if bottom die and top die is not aligned properly. So we are getting this type of defect that is known as forging. Some of the material came out and folding. So forging lap is caused by folding of metal on the surface of forging, usually when some of the forging metal is squeezed out between the two dies. Now this here are many cracks. So this is internal cracks. Because this is see here in ingot there is cavity. But during forging, if we are not using proper temperature, proper sequence of forging process, so there is chances to increase the crack. So that is known as forging burst. Sometimes this burst is internal, sometimes this burst is external. Now see this is the external burst. So a forging burst means many small cracks. Now this casting discontinuity. Now see this is the mold, and this cavity means our required job. Hmm? And we are pouring from here basin and this gating process, and the molten metal goes here. Some of the molten metal flash here and it solidifies. And when this metal and this metal not fused together, then we can say cold shut. Uh, Now see here, this is a big cross section. This is also big, but this is small cross section. So this will solidify first and this will take time. And here also shrinkage rate is different. Here shrinkage rate is different. That's why trace generated at junction, and we are getting cracked. This is also cracked, but we are getting at small and big cross section. That's why we are saying hot tear. So hot tear occurs when there is unequal shrinkage between light and heavy section. Now see here also shrinkage cavities, because suppose this is fill. Now here we are pouring molten metal. Okay, we are pouring molten metal, and here suppose fill full of molten metal. After solidification, the solidification start from outside area, right? And inside there is less lack of material. Then we can say shrinkage cavity. Uh, So micro shrinkage is usually many small subsurface holes that appears at the gate of casting. Micro shrinkage can also occur when the molten metal must flow from thin section into thicker section of casting. Blowholes are small holes at the surface of casting caused by gas which came from the mold itself. Many mold are made of sand, and when molten metal comes into contact with the mold, the water in the sand is released as steam. Porosity is caused by entrapped gases. Porosity is usually subsurface but can occur on the surface depending on design of mold. So see here this grinding also generated crack, because sometimes we are giving pressure. So due to heat and pressure, we are getting small cracks. This also heat treating cracks. Heat treatment basically this crack we can get while we are doing quenching. A quenching is a process where we are heating the material above recrystallization temperature, and suddenly we are suddenly we are cooling in water, and that's why the material will change to martensite. It will be more hard, and so there are more stress inside, because suddenly we are cooling. Heating and suddenly cooling means there are more stress. That's why we are getting sometimes crack after quenching process. So this is also heat treatment crack. So fatigue crack. See here, here is crack. Here also crack. This is erosion here, because mechanical wear and tear. That is known as erosion. This is corrosion. Then welding, we already discussed. There is some see here. Here, see that is here. We can say welding. We can say there are many defects. First one is undercut. In case of undercut, the base metal is melted. Uh, and suppose the base metal and the second defect I will explain with diagram first. Here, suppose this base metal is melted here, then we can say undercut. Okay, we suppose this weld metal is not fused with base metal. This is base metal, this is weld metal, and there is cavity, there is gap. Then we can say sidewall fusion. And you suppose this weld metal is not filled here up to thickness, or suppose here is insufficient filling of weld metal at root, then we can say lack of penetration. Sometimes we are getting transverse crack, sometimes we are getting longitudinal crack, and longitudinal crack we are getting because of shrinkage. Because of crack, whatever getting crack, that is because of shrinkage. And this incomplete penetration we are getting because of if your electrode traveling speed is high, if current value is low, if there is insufficient root gap. And similarly for undercut, if your electrode manipulation is not proper, if current is high, traveling speed is high, so in that case we are getting undercut. Okay, and side wall fusion also again if improper weld preparation. And second thing is suppose your current is low and your electrode traveling speed is high, so there are chances of lack of penetration. So these are the defects which came. And one more defect, there are many defects in welding. The second last, the not second last, but the slag is there. When we are doing SMAW welding, we are using electrode which has flux coating. So while electrode melted, the flux coating also melted. And the purpose of that flux coating is to protect the weld metal from environmental gases. But once your welding is completed, we have to remove that flux, melted flux. If we are not removed from weld and we are doing second welding layer, then we are getting that slag is there. So and the spatter also there. Sometimes spatter means if when you are doing welding, if your current value is not proper, then some of the molten metal hashes is directly goes to on the weld base metal, that is spatter. So these are the some of the defects in welding. So here we are going to stop in a separate session. We will see in the detail way what forging discontinuities, casting discontinuities, and welding discontinuities, and which method is suitable for detection of which type of discontinuities in forging, casting, welding. So we have one PowerPoint presentation which includes all with cause and corrective action also there. So we will go in separate session for that. So thank you very much. If you have any doubt, please ask me. Otherwise, we can solve the quiz. Basically, we can start quiz, and then if you have any doubt, we can discuss.